Alright, now this height, which is 11 meter, minus this, we have the perpendicular. This is the perpendicular. BE is perpendicular to CD. Okay, so that is forming a rectangle. Now in right angle, this is right angle triangle. The reason is the right angle triangle. Why it is the right angle triangle? This is right angle, you can say. So AB sphere. How do we prove this? Okay, so this is 6 meter, 12 meter, and that is 5 meter. So let me find the solution. Alright, so if I find that is the right angle triangle. So BD in a right angled triangle, BDE, we have, okay, nothing is given, no angle is given, no problem. We can see here two poles of height 6 meter, 11 meter, and vertical on the ground with the distance between their feet is square and the distance from the top. So the distance from the top is to be calculated. It's a right angle triangle because we know that 5, 6, 13. So the distance BD in right angle triangle, BD square is equal to BE square plus DE square by Pythagoras theorem. By Pythagoras theorem. By Pythagoras theorem. This is hypotenuse square equal to the sum of the squares of the other two sides. So this is 5 square BE, B is 12 square, plus 5 square, DE is 5 square. So this is equal to 144 plus 25, 169. So this is square, BD is equal to therefore BD is equal to square root of 169, which is 13. Which proves to be a right angle triangle. So 13, the square root is calculated. We see here that the square of this, the square root of this is 13. So 13 is square equal to sum of the squares of the other two sides. That means it forms a right angle triangle. So this is 13. So the distance between the top is 13 meters. So this is the answer here. Hence, the distance between the top, distance between the tops of the poles is equal to 13 meters. This is the answer here. Okay, so distance between the tops is 13 meters. That is the answer here. Finally, we have. And this is question number 3. Now let us take question number 4. So guys, what is question number 4 say? Let me check. Now question number 4. Okay, after this we will clean this. Question number 4 now. Okay, question 4 says, from the top of the tower, 50 meter high, the angles of depression, okay, angles of depression of the top and bottom of a pole are observed to be 45 degree and 60 degree respectively. Okay, find the height of the pole if the pole and tower stands on the same plane. Good point. From the top of the tower, 50 meter high, the angle of depression of the top and bottom of the pole are to be 45 degree and 60 degree. Find the height of the pole. Okay, so from the top of a tower, let me take. This is tower here, and a pole is here. Now it says from the top of a tower 50 meter high, This is 50-meter high tower. On the top of the tower, 50-meter high. Top of the tower, 50-meter high. This is 50-meter high tower here. 50-meter high tower. All right. Let us take from the top of the tower, 50-meter high, the angles of depression of the top and bottom. This is top and bottom. Angle of depression of the top and bottom. Now, if I take a parallel line like this, so this angle and this whole angle, what are given to us? Let me take first this angle and then this angle. So, angle of depression from the top of a tower 50 meters high of a top and bottom of a pole are object being 45 degree. This is 45 degree and bigger is 60 degree. 45 degree and 60 degree respectively. Now find the height of the pole. The pole and top distance on the same ground. Alright. Guys, this is, let me take, if I draw a perpendicular from this point on top of the pole here. So let me take, this is AB now, is this AB and this is CD. And this is E point here. Now try to understand what is given to us. Now this is 60 degree we are given and this is 45 degree. Why? Because this angle is equal to this angle, alternate angle. This whole 60 degree angle is this 60 degree angle. Now let us take what is the point. Now from the top of the tower 50 meter high, the angles of depression of the top and bottom of the pole, top and bottom of a pole are object to be 45 degree and 60 degree respectively. And the height of the pole here, this height of the pole, let me take H. This height of the pole is required to be calculated. This is also H here, from this point to this point. Now, so this above height will be H, 50 minus H. This is 50 minus H. Now, if I take this distance between them is X here, the distance between their feet of the two tower and build and pole is, let me take X meter. Okay, that's quickly. Find the height of the pole if the pole and tower stands on the same plane. Okay, so this is X here. So either we find out this 50 minus H upon this. First, let me take this side. This is X point here. Now let me take what is given to us. What are given to us? We are given here AB and CD. AB and CD are, first is tower, are pole, first is AB is tower and pole, where height of the tower is given. Height of the tower AB, we have taken AB, is equal to 50 meter given. 50 meter given. Angle XBC, angle XBC is equal to 45 degree. Angle of depression is known as angle of depression given. And angle, next angle, XBD is equal to 60 degree. Is also angle of depression. Okay, given. These two angle of depressions are given. XBD is 60 degree and XBC is 45 degree. Okay, so height of the, to find height of the pole height of the pole CD. CD, height of the pole, which is we have taken as H, is to be calculated. So we have the solution. What we have? We have BE is equal to AB minus AB minus EA. Sorry, this is AB minus AE, which is H here. AE is H, A minus, so this is A. AB minus A, AB is 50 and AE is equal to CD. A is equal to CD, which is 50 minus H here. Because CD is H we have taken. Okay, so this is BE. B is equal to 50 minus H. Total is 50 and this is H here, H minus. Alright, so this is we have taken. Now in okay, angle, let me take. Therefore angle BCE is equal to angle XBC. This XBC is equal to 45 degrees. Okay, alternate interior angles. Alternate interior angles equal there. Okay, and second angle BDA is equal to angle XBD equal to 60 degrees. They are also alternate interior angles. Alternate interior angles, same thing. These two we have taken. Okay, now let us take here solution. Now let me take first in this triangle either or in any. We can then find out height. 50 minus H we have to find out. So let in triangle this one. Let in the right angle triangle. Let in the right angle triangle BDA we have, or in right angle triangle BDE, right angle triangle BDA we have tan 60 degree. Tan of 60 degree equal to BA upon DA. This is BA is 50 upon, or AB is 50 upon X. Tan 60 degree is root 3. Tan 60 root 3 equal to 50 upon X. This implies that X equal to 50 upon root 3. Okay, this is this value X. Let me write here. We have calculated X equal to 50 upon root 3. This we have just calculated. Now let us take. This is first equation we have found. Now come in. Now this value CE. What CE is equal to DA equal to X, which is 50 upon root 3. Which means CA is also 50 upon root 3. So this is X here. So this CE is calculated. Now in the right angle triangle we see. So now in the right angle triangle BCE we have tan of 45 degree is 45 degree angle is equal to BE upon CE. B is 50 minus H upon CE. CE is 50 upon root 3, which is X here, and tan 45 degree is 1. This is 1 equal to 50 minus H upon 50 upon root 3. Root 3 will come here. That means 50 is equal to, take this cross multiplication, 50 will give us 50 root 3 minus root 3h multiplying by root 3. This root 3 will come in the numerator. Therefore, root 3h taken to that side. Let me solve above. Okay, let me solve here. Therefore, root 3h taken to this side, it will become positive, minus root 3h taken to left hand side, it will become positive here. That is equal to 50 root 3 minus 50. Take 50 common, root 3 minus 1 is meter, h equal to, therefore h equal to, and root 3h equal to this, root 3h equal to this value, and therefore h equal to 50 root 3 minus 1 upon root 3. This is the final value of h here. Height. So height of the tower, height of the pole we have to calculate. Find the height of the pole. H is the height of the pole which we were calculating. This can give us 50. We multiply by root 3 in the numerator and denominator. It will give us root 3 minus 1 into root 3. Now upon 3, why equal root 3 into root 3 is 3 in the denominator. This root 3 will come in the numerator. It will give us 50 into 3, because root 3 into root 3 is 3, minus 50 root 3 divided by 3 only. Root 3 into root 3 is 3, 50 into 3, 150, that is 150, 5 3 15, 150 minus 50 root 3 divided by 3. This is the height of the pole required, but let me solve it further. It gives us 150 minus 50 into 1.732. If I just multiply 50 into 1.732, will give us 0, 5 to 10, 0, 1 carry, 5 to 15, 1 16, 1 carry, 5 to 35, 136, 6, 3 carry, 5 and 3, 8, 86.6 meter. This multiplication is divided by 3 here. So let me write here. Therefore h equal to 150 minus 86.6. 86.6, this value is multiplied into 50 into root 3, this value divided by 3. So finally we obtain here, let me take 0. 10 minus 4 is 10 minus 6 is 4, 1 carry 7. Okay, then 10 minus 7 is 3, 1 carry again 8, 9. 15 minus 9 is 6, 163 here on 63.4 here upon 3. This is height of the pole. So height of the pole is this much, 150 minus 86.6, that has given us, this is 150.0, suppose this is 86.6, 4 carry. Now then 10 minus 7 is 3, then 10 minus 15 minus 9 is 6, only 63.4, this is 63.4 upon 3. If I divided by this, 3 1 3 1 1 3 1 1 10 3, 21.3 meter, 33 meter, 21.33 meter. This is the actual height of the pole. This is the answer here. Okay, so try to just understand that what is the logic given here. That logic should be understood, and after that we can solve it. The final answer 20 is the pole, height of the pole here, which was calculated, which was to be calculated. Okay, so this is find the height of the pole. The pole and this is standing on the same ground, no problem. This is question number 4, finally completed. Let me take question number 5. Now question number 5 here. Okay, Question number 5. Before that, let me clean this. Let me clean the board here. Okay, now question number 5, let me talk about question number 5 here now. Okay, question number 5, perfect question. It says that a 1.5 meter tall boy is standing at some distance from a 30 meter tall building. Okay, the angle of elevation from his eyes to the top of the building increases from 30 degree to 60 degree as he walks towards the building. Find the distance he walked towards the building. That is the point. Okay. So what does it say? It said that there is a building which is total 30 meter tall. 30 meter tall, there is a building here. The total height is 30 meter tall. A 1.5 meter boy, okay, because they are standing on the ground here. So this is the ground. The boy is 1.5 meter tall. From this, the boy observes, let me take, this is his eye here. Okay, from here he observes the angle of that a 1.5 meter tall boy is standing at the some distance from a 30 meter tall building. The angle of elevation from his eyes to the top of the building increases from 30 degree to, this is 30 degree angle of elevation, a straight line. So this angle of elevation is 30 degree first. Then he walks towards the building, and from there then his angle of elevation is 60 degree. Now it becomes 60 degree. It says now it is 60 degree, and this is his height. The boy is observing from this, we can say. So 1.5 meters to be subtracted from this. This is 1.5 meters up to this point. The building is AB, let me take. AB is the building here. Okay, and this is boy is CD, ABCD, and this point is E again. We take this is the E point here. So what is the actual height? And this E and this is F. Let me take. First, let me take this is F, or this is E. Sorry, this is F. E and F. Okay. Now it says. Now try to understand the question. A 1.5 meter tall boy is standing at some distance from a 30 meter tall building. The angle of elevation from his eyes to the top of the building increases from 30 degree to 60 degree as he walks towards the building. As he walks towards the building, okay, then his angle of elevation increases from 30 degree to 60 degree as he walks towards the building. Find the distance he walked towards the building. That's the point. Okay, towards the building. What is the distance? This distance we have to find out. Now distance between the boy and this is not given, no problem. This distance we have to find out. Let me take this as x distance here. This is x distance. which he has traveled from D point to E point, okay, towards the building 30-meter high initially. So this height BF is equal to how much? So BF is equal to AB minus AF. AB is 30 meter minus 1.5 meter. It is 28.5 meter left. This height is now left 28.5 meter. Okay, so if I take 30 degree in this whole triangle, we can find out the total distance. Then in 60 degree, if I take 60 degree and 28.5 meter, this height, okay, then we can find out this EF distance. So from DF minus EF will give us this walked distance. Okay, so what is given to us? Question number 5 here. What is given to us? Let me write. Given here, CD equal to 1.5. This is the height of a boy. Second, AB equal to 30 meter. Height of the tower or height of the tower. Of the tower we can say, because we have discussed about this. This is the height of a tower. Building, sorry, not tower. Height of a building. Height of a building. This is 30 meter tall building. Okay. Angle of elevation from his eyes to the top of the building increased from 30 degree. Now the two angles are increasing. So let me take the angles here. What is given here? Angle BDF. Let me take. BDF equal to 30 degree. Angle BEF equal to 60 degree. Here the angles of elevation. Angles of elevation of the top of the building. This is top of the building's elevation, angle of elevations. From this point to this point, he has walked. Initially, his angle of elevation was 30 degree at the top of the building. And after he has walked X distance or X meter distance, at E when he reached, then the angle of elevation becomes 60 degree. This is the given. This is given to us. Okay, so the two angles of elevations are given to us. What we will find out? We find that what the distance he has traveled. We find DE distance traveled by the boy, walked, not traveled, but walked by the boy. Walked by the boy from D to E when his angle becomes 30 degree to 60 degree. Okay, so angle 30 to 60 degree, that is given to us, and we have written down already a solution. Solution here. What is given to us? We have just calculated that BF is equal to AB minus AF, that we have already written. That is 30 minus 1.5 meter. That is equal to 28.5 meter now left over. So in a right angle triangle, which one? First let me take BF or BEF. We have BF, we have 1060 degree. 1060 degree, this 60 degree. Because this EF, let me take this Y distance. Okay. So 1060 degree is equal to 28 point, that means BF upon EF equal to 28.5 meter divided by Y. Tan 60 degree is root 3. Okay, root 3 equal to 28.5 upon Y. This implies that Y is equal to 28.5 upon root 3. Let me take this in first equation. This value of Y is calculated. Now in right triangle, this bigger one. Big right triangle. What is that? Okay, so this is Y value. Let us take in a right angle triangle. Now in a right angled triangle BDF we have tan 30 degree is equal to BF upon DF, that is 28.5 meter divided by DF. BF is 28.5 meter and DF is x plus y, or let me write in terms of sides. This is DE plus EF. This is 28.5 upon x plus y. Okay, this x plus y therefore is equal to tan root 3 is 1 upon root 3, tan 30 degree is 1 upon root 3, equal to 28.5 upon x plus y. So this implies that x plus y is equal to 28.5 into root 3. Okay, now if I find this is x plus y here, total distance. Now if I substitute the value of y which is there, then x is calculated, then x plus y will be, so this y value substitute here, substituting the value here of y, so x plus y, but x is, or if I just find out total distance, this is the total distance here. Okay, let me take this is x plus y here. X plus y we have to calculate, right? So then this y will be, so this distance x already calculated, therefore x equal to x we have to calculate because what distance he has traveled. X equal to 28.5 root 3 minus y, substituting the value of y is 20